This is problem 439. They want us to determine the moment of the force F about the door hinge at B. Express the result as a Cartesian vector. I definitely recommend looking at the book for the drawing there. But I wrote out, or I did it, I went ahead and did the drawing, which I recommend that you all do also because it helps you sort of understand better what's going on. But they want us to find the moment about B, so I wrote that for find. And so we want to do the moment about B. So let's see. So the moment about B is going to equal the um, perpendicular distance, or the R cross F. And R is from that point B to any point along that action of that force F. So anything from that corner of that door at C all the way to D or anywhere beyond. I'm going to do from B to D, or sorry, the position, yeah, from B to D because that's just going to be easier to get to. It doesn't change in the Z at all. So I'm going to do B to D. And I think that'll make it a little bit easier for us. And that, um, and so we'll need to know that position vector from B to D. I'm just going to start with that. From B to get over to D, we're going to go, let's see, 3 feet in the Y direction. So 3 feet in the Y, which would be J. And then to get over to D, we need to go in the negative X direction. So negative, and it's going to be 5 minus that 1.5 feet. And that's in the I direction. So I'm going to rewrite that just with the I first. So 5 minus 3.5, or 5 minus 1.5 is going to be 3.5. So negative 3.5 I plus 3J, and that's in feet. And I'm just going to look back at the figure and make sure that's right. So if I'm at B and I want to go to D, so I need to go minus 3.5 in the X direction. So that would get us up to here. And then 3 feet in the positive Y direction. So that'll get us to D. So that looks good. So I did a little check. And then F, we know F equals 80 pounds. Let's see. Yeah, we know F equals 80 pounds. How are we gonna, let's see, yeah, so we know F, the magnitude of F is 80 pounds. We could do a unit vector to figure out what direction it's pointed in, because we know where C is and we know where D is. So let's see, we want to figure out the unit vector from C to D, and that's going to equal the position vector from C to D divided by the length of that position vector from C to D. And that's going to give us, this is the scalar of F. The vector F will equal 80 pounds times that unit vector from C to D. So that'll give us the direction. So the position vector from C to D, so we just go start at C and we want to go over to D. So to C to get to D, we need to go down, so we'll need to go down in the Z direction. And we know that angle is 45 degrees. So let's see. We know it's 45 degrees, and we know that the length of this door is 4 feet. So 4 feet times cosine of 45 degrees will get us down. Actually, I'm gonna write this separately. So 4 feet times cosine of 45 degrees. And actually that's wrong because we want to do the sine of 45 degrees, right? We're trying to find this distance here, how far down we need to go in the Z direction. So it's actually sine of 45 degrees. That'll be in the z direction, and it's going down because we're going from C over to D. So it'll be in the negative k direction. And now we need to cut over to point D. So if we go in the y direction, we're going to move in the positive y direction. And it's going to be that we need to get this bit and then also add it to that. So that'll be 4 feet cosine of 45 degrees. And then plus 3 feet. And that's going to be in the j direction. It's in the positive j direction. And then for the x, we need to go back to that point D, right? So we'll go negative 5 feet, and that's in the I direction. So I'm going to rewrite it and do it in the correct order. So negative 5I plus, I'll go ahead and calculate that out, 4 times the cosine of 45, and then add 3, so I get 5.828. That's J, and everything's in feet. And then minus, and that 4 times the sine of 45, 2.828. Okay. So if I was doing a test, I would want to go ahead and check through, make sure all those calculations were right. And then I'm also going to check. I'm going to start at C. Let's see if we go down negative 5I. So negative 5 in the x direction. So that makes sense. Plus 5.828 in the j. Plus 5.828 in the j. That also makes sense. And then in the k, we need to go down 2.828 in the k direction. That makes sense. And that unit is feet. And then we can figure out what the magnitude of that vector is. So that's going to be the square root of 5 squared plus 5.828 squared plus 2.828 squared. So that's going to give us, let's see, 8.183, and that'll be feet. So now we can do that unit vector, right? So now we have the top, and we have the numerator and the denominator. So I'm going to, so it's just a little bit weird. I'm going to copy this over just so I can make sure I get it right when I move to the next page. And this is problem 39. I just copied the header over to the other ones. Let's see. Let's take this and make it a little bit smaller. All right. So now we have that U is CD. It's going to equal that position vector from C to D, so that negative 5I plus 5.828J minus 2.828K, and that's divided by that 8.183. And that's feet on the top, and it's feet on the bottom. So the units cancel out, which is good. Now we can figure out what our unit vector is. I'm just going to erase the stuff I'd copied over. And so the unit vector from C to D equals, let's see, 5 divided by that is negative 0.611I plus 0.712J minus 0.346K. And no units, that's right for a unit vector. And let's see, so now we have F. So F equals 80 pounds times that unit vector from C to D. So that's going to be 80 times each of those, so 0.611, 48.88I, that's negative, plus just did 0.712 times 80, which is 56.96J, and then minus, so that's 0.346 times 80, 27.68K, and that'll be in pounds. So now we can set up our determinant, right? So move this over. So back to our equation. So we have that R, our moment about B equals R, or that position vector from B to D, crossed with the F. So I'm going to write it in determinant form. So the moment about B equals I, J, K. And the R it's R cross F, so I'll start with the R for the second row, negative 3.5, 3, and 0. And then for the F, that's in feet. For the F is in pounds, it's negative 48.88, 56.96, and negative 27.68. Well, you can't read that, can you? Let's see. 8. So the moment about B. So it might be worthwhile for you to figure out how to do this in your calculator. It might save you a little bit of time. I'm just going to do it manually here just to make sure y'all know how to do it. So we'll start with I times, and then we do this 3 times negative 27.68, and then minus 0 times 56.96. So 3, 27.68 times, so that's negative 83.04, and then minus 0, and then minus J times, and then we do the same thing where we go, so you sort of cross out that J side, and it's negative 3.5 times 27.68 minus 0 times that 48.88. So calculate 3.5 times 27.68. That's 96.88. Negative times negative is a positive, and then minus is a 0. And so you see, this is why it was better to, or easier to pick that position vector from B to D instead of going all the way up to that point C, because we have that 0, which makes it a little bit easier. And then plus, and then K times negative 3.5 times 56.96. And then minus 3 times negative 48.88. Minus negatives, so that's plus. So we get negative 52.72. So that's what we get for our moment. So we get moment about B equals negative 83.04 I minus 96.88 J. Oh, minus 52.72 K. And that's in pounds times feet. Because let's see, this row was feet, right? And then this row was pounds. So that's it.